We're back in 11.2 where we're talking about classifying reactions. In the last podcast we talked about classifying reactions using the terms combination, decomposition, single and double replacements, and combustion. We also then introduced you to a set of three reactions: acid-base, precipitation, and redox reactions, which are right here. By the way, these three in particular, the acid-base, the precipitation, and the redox, those are not covered in Chapter 11 in this textbook. In a previous textbook they were, but they're not in this one. So they're not going to be showing up on this particular test directly. However, we will have a whole section on precipitation reactions in this chapter. The acid base and the redox are going to be coming in chapters in Chemistry B, but I do want you to be aware of those so that you have at least heard them once before encountering them next trimester. All right. There's two more types of reactions, and these are simply being classified by their heat transfer. You have what are called exothermic and endothermic reactions. Exothermic reactions release heat, while endothermic reactions absorb heat. If the exothermic reaction releases heat, if you put your hand up to that, that's going to feel warm. On the other hand, an endothermic process, because it's absorbing heat, if you put your hand up to that, that's going to feel cold. All right. Now, as an example of an exothermic reaction, you can use, again, any combustion reaction. One of the more exothermic reactions known as a single replacement reaction, it's a thermite reaction, where you take aluminum, react it with rust, believe it or not, and it's going to form aluminum oxide and iron, and it actually comes out as molten iron because the reaction is so exothermic and so hot it actually melts the iron and then it quickly solidifies. But this thing releases a tremendous amount of heat and energy. I guess I'll just write in energy as well, because it's not only heat that comes off, a tremendous amount of UV light comes out as well. Alright? Now, in terms of an endothermic reaction, you can actually try this one at home. You can actually take any citric acid. I'll just write this as a word equation. Let's just say lemon juice. And you react that to baking soda. Okay, the products aren't so important here in this case, but the fact is it will feel cold. Go ahead and give it a try at home, and you can impress your friends and family with that one. All right, so you have exothermic and endothermic processes. Now, the next thing I do want to talk about is how you can actually predict whether or not some of these reactions are going to occur, and I want to start off with single replacement reactions. You can predict single replacements using what's called the activity series of metals. This is a list of metals that tells you which metals are more active than others. The most active metal is going to be lithium, with the least active metal, at least in this particular list, being silver. And all this means is that the more active metal will prefer to be in a compound, while the less active metal will prefer to stay on its own as an element. For example, in this first reaction, you have aluminum that's replacing the copper. And if you look at the activity series, sure enough, aluminum is higher and more active than copper. So the higher on this list that you are, the more active that you're going to be, and any of the higher elements are going to replace any of the metals that are below them on the list. All right, so that reaction does in fact occur. In this second example, you have zinc that's trying to replace the hydrogen. Well, let's go ahead and check the list to see if in fact that should occur. Here's the zinc metal. The hydrogen, which of course is not a metal, but it does behave like a metal, is lower on the list. So the zinc is more active and in fact can replace the hydrogen in the hydrochloric acid. So that reaction will also occur. Now in this third reaction, you have iron that's trying to replace the magnesium. If you locate the iron, iron is right there. Magnesium is more active than the iron. So the iron cannot replace the magnesium in magnesium chloride. So we're just going to write no reaction. That does not occur. Can't occur. It's impossible. Okay. Scrolling down. Copper with nitric acid. Now, if you look at your list, copper, which is right here, is lower on your list than hydrogen is right here. So the copper cannot replace the hydrogen in nitric acid. Now that doesn't mean that a reaction won't occur. It just means that a single replacement reaction is not going to occur. In fact, if you do put copper in with nitric acid, a different type of reaction occurs that releases the brown nitrogen dioxide gas. But it is not a single replacement reaction. And the activity series predicts that in fact it will not happen. This next reaction with potassium and water. At first glance, this might be a little bit hard to see what's going to happen, except for the fact that if I changed water to read as HOH, oftentimes we write water as HOH because you can see the hydrogen and then the hydroxide involved with the water. And in fact, it's not hydrogen and hydroxide, but when you do reactions, it behaves that way. The potassium, it would appear, would want to replace that hydrogen. And if you look on the activity series, potassium is way up at the top. I'll put a star by that one. And so that is more active than the hydrogen and will in fact replace it. So in the products, you're going to get potassium hydroxide. The potassium will replace one of those hydrogens. What you're going to be left with is the hydrogen that goes off on its own. Of course, that just goes off as H2. That'll be a gas. And this will be aqueous. So in fact, that reaction does occur. And scrolling down, last one, we have silver trying to replace the lead in lead nitrate. Well, silver, once again, is all the way at the bottom. And most of the time, silver is not going to be able to replace anything, including lead, which is more active than the silver. So if the silver tries to replace that, that in fact will not occur. Okay? So you will have to predict whether or not a single replacement is going to occur. You will not have to predict the products of a single replacement. I'll simply give you a list of reactions and ask, will this reaction occur using the activity series of metals? And you'll just simply have to answer yes or no. Alright? That concludes 11.2 on classifying reactions.